this with
Would you like to start perhaps a webinar?
Yeah. Let's see, so how many we are?
Around 15, around 15.
50, yes. Okay. Bene, since we are already at 2 minutes after 2, let's start the webinar that is focusing on innovation. This is following the event that we had in February. And since then, PETCORE Europe has continued to grow. The number of our members is growing almost on a daily basis. We are very happy. It means that PETCORE is really perceived as the voice of a value chain. 1 year ago, we signed the Antwerp Declaration, where the European industry, the European manufacturers were somehow declaring the problems, the problematic situation where the industry is in Europe. And one of the answers that we got from the Commission is that the Commission is ready to support Europe in recover competitiveness, but the industry has to push on innovation. So innovation is becoming central. As a matter of fact, in 2024, we had the first session of innovation at our annual event, and we had almost 5 papers presented. This year, in 2025, we exceeded 16 papers showing how much innovation is close to the heart of our members. So what we are trying now with this webinar is to give a proper space to the presentation that for a number of reasons were very compressed during the event. On top of innovation, we have Lee Cohen presenting from Argentum the status of how we could fund this innovation. And we're looking forward to Lee's presentation to better understand how to get the European funds that are quite relevant. Having said so, I leave the floor to Roberto, that is going to be the master of ceremony for this afternoon. Welcome, everybody.
Thank you very much, Antonello, and thank you all, and good afternoon to all. So let me start with, the main rules concerning antitrust. So what we can do, what we cannot do. Let me list briefly what we cannot do. So we cannot discuss about the prices, of course. So any link to prices is forbidden. The same for production data, and the same for market shares, customers, investment, and trends. So everything which is related to market and commercial is something that we shouldn't touch, and we will not touch during the today presentations. So let me first say that the title of the webinar, Innovation Projects and European Fundings, is, I think it is very appropriate, because innovation is made by sometimes great ideas, and we will see several of them today. But those ideas, those innovations, most of the times they do need to have proper funding. And that's the reason why, indeed, we are going to start with Lee Cohen and Argentum, which is specialized in European fundings. Then we will have technical papers split into 2 sessions. And after the first session, there will be question and answers, and obviously a coffee break. Then we'll restart with a second session, and again, a question and answers at the end of the block. Let me introduce, first of all, say Argentum. Argentum is a consulting firm specialized in securing non-dilutive funds and R&D incentives for technology companies across Europe. So very much focus on what we are going to present today. And Argentum leads hundreds of clients towards higher participation rates in EU and locally funded projects across all technical sectors. There is a dedicated team of analysts, project managers, team leaders, business development specialists, and grant writers which are committed to develop the clients, Argentine clients, winning project proposals and securing funding through a multi-subdivision strategy. The presentation will be performed by Lee Cohen, who is the business development and sales manager in Argentina, and she is the one engaging with innovative companies and assisting them in securing non-dilutive funding for their upcoming technologies R&D project through multi-submission strategy, as we said before. So I'm very, very pleased to leave Lee Cohen to introduce Argentum.
Thank you, Roberto. Thank you very much. So good afternoon, everybody. Thanks very much for joining today. So today I'll be discussing non-dilutive funding opportunities, as Roberto mentioned, through our multi-submission strategy. So to start, I'll just share a little bit about what you're going to see. Today, I'll basically be going over the stages of applying, looking at upcoming calls and funding rates. And then to summarize, I'll explain a little bit about how we do that through our services and give you some food for thought. And then obviously we have the question and answer session towards the end of the session. So I'll start by explaining basically when targeting non-dilutive funding, there are some notions and definitions to be presented. So first, regarding the thematic of the call. So we call a funding opportunity bottom up, as you can see on the screen. It's when the call is open to all fields of technology, and top down is when it's a specific call that's aligned with funding sources priorities in terms of field and focus areas and so on. Then we divide the calls by their funding source or their funding mechanism. So we split this into 3 different levels. So national, bilateral or intergovernmental funding, and a European level. Lastly, we consider the type of application setting. So whether the submission is a single applicant or as part of a collaborative project, which is a consortium, and it can be a small or large consortium. So some of the bottom-up calls I'll be speaking a little bit about in more detail are the EIC Accelerator, Pathfinder, Eureka, and Sprint. So when we're looking at the European Innovation Council, they have 2 main paths. We're looking at the EIC Accelerator and the Pathfinder. In the EIC Accelerator, it's an independent application on an EU level with a grant of 2.5 million euros and an option of 10 million euros for equity. The accelerator supports the later stages of technology development as well as a scale-up. The technology component of an applicant's innovation, therefore, has already been tested and validated in a lab or other relevant environments prior to the accelerator application. Projects to be selected should provide a strong commercialization strategy that aims at creating new market or disrupt existing markets. And besides the open call, there are various challenges each year. An example of a challenge in this year's work program is the biotechnology-driven low-emission food and feed production systems. Looking at the EIC Pathfinder, so the open call we can apply with a small consortium of at least 3 independent legal entities, each established in a different country, and at least one of them must be an EU member state. However, like the accelerator, there are some challenges. And here, if you're applying for a challenge of the call, then it's actually able to submit by a single applicant, or even 2 applicants are allowed. So the funding per project is up to 3 million euros for the open call and up to 4 million for the challenges. And another example for one of the challenges of this year is waste to value devices, circular production of new renewable energies, chemicals, and materials. So in general, the Pathfinder looks for a more convincing long-term vision of a radically new deep tech that has the potential to have a transformative positive effect on the economy and society. Moving on to Eureka. Now, Eureka is a direction for intergovernmental funding, generally for bilateral R&D collaboration between SMEs. In some cases, though, universities and research institutes can join small Eureka consortia and apply with SMEs to accelerate the transfer of their research results into pre-commercial projects. The calls have recurring deadlines, mostly twice a year. And an example of one of the calls under the Eureka program is the Eurostars. This is a bottom-up bilateral collaboration, and this is between a long list of participating countries that Eureka themselves publish. Furthermore, there are also bilateral calls between specific countries. For example, Germany, UK. There are thematic calls within Eureka, such as ITEA 4, which is allocated for certain software innovation, which I'll delve a little bit deeper into later on. And also, finally, they also have a call which is directed for market feasibility studies. This is more dedicated to higher TRLs, which is a technology readiness level of the project, such as the Innovate call. So here it's an opportunity to apply for a grant that's focused on marketing and commercialization solely. And of course, I'll be happy to discuss relevant calls within the Eureka project towards the end. Another call, which is relatively new, it's a couple of years old, is Sprind or Sprindi. It's a funding opportunity on a national level. However, it is open for applicants worldwide. So you can apply as a single participant or with a small consortium. If you're located outside Germany, I usually advise to collaborate with a German partner. It can be a company or a research institute. And this is in order to strengthen the focus on Germany and strengthen the application as well. The funding budget here is actually unlimited. Therefore, it's very attractive and we can get anywhere between 1 to 70 million euros, but it is very competitive due to that. However, if we bring up a project idea that is highly disruptive and is a radical innovation, we should definitely consider applying for this grant as a single applicant as well. The application is quite short, the call is open all year round, so we can easily fit into the submission plan. Over the next couple of slides, I'm going to discuss what we call top-down funding opportunities. So they're more thematic, specific calls. I'll address some other interesting options for the different clusters from Horizon Europe or from the European Union, which they themselves have published. I won't go into all the details here, as there's a lot, but I'm happy to discuss again, should one of these calls fit in with your field of technology. Now I've put here on the screen, you can see cluster 1, which is generally for health. And I've put here EP-PERMED and TransCan as a couple of options. Now, the European Partnership for Personalised Medicine is an intergovernmental funding scheme, which means when a project is successful, the funding takes place on a national level. The EP-PERMED brings together academic, clinical, public health, and private research teams. This yearly focused call always looks at personalized medicine approaches, which can include different aspects through companion biomarkers that can support individualizing treatments, approaches, and selecting monitoring in the most effective therapy. This call has a fairly large budget of around 45 million euros, but the funding per project differs per application, per national funding body. Looking at TransCan very briefly, as you can see on the screen, it focuses on cancer research and treatment. Again, another EU funding direction which focuses on addressing and understanding and preventing cancer. And this obviously is a worldwide health concern, but it does have a continuous advancement on the research and treatment approaches. Next up over here, cluster 4. This is focusing on digital industry and space, but it does slide and glide into other clusters as well. I decided to mention a couple of calls here, Celtic Next and ESA, as they do have quite a few different opportunities for all clusters to be part of. Celtic Next and the Celtic Next Plus program, they're part of Eureka, which I mentioned just before. This is a network that has existed for over 15 years. And this Celtic Next program really focuses on next generation communications and transformation. So bearing in mind that the Celtic Next is primarily for that reason, it does stimulate and orchestrates international collaborative projects looking at information and communications technology. For this call, we have 2 recurring deadlines a year. One is coming up in the spring and another one is in autumn. And again, this has a relatively large budget for consortia application. It can be up to 70 million as well. Moving on to ESA, the goal of this activity is for businesses to develop a new commercial service that utilizes one or more space assets. Now, it does sound quite far-fetched, but it is including satellite communication, Earth observation, navigation, human spaceflight technology, and many more. There are 2 tracks under this call. We have the feasibility studies track and the demonstration project tracks. This call is always open for applications, and you can apply as a single beneficiary with a budget between 500,000 euros up to 2 million euros, depending on the track that you choose. Moving now into cluster 5, which is mobility, energy, smart cities and such. I've put here on the screen Eurogia and EIT Urban Mobility. It's just to give you an idea of the different aspects and the different opportunities, again, that we can reach out to. Eurogia aims to contribute for a sustainable environment. Eurogia 2030 is on the front line in the energy field to achieve clean carbon neutrality goals. So through low carbon technologies, R&D solutions, Eurogia aims to contribute for a sustainable environment, for the reduction of climate change, and for sustainable growth. This program is intent to address issues in the energy market in order to develop the Eurogia 5 Ds, which are decarbonisation, democratization, digitalization, deregulation, and decentralization. Here we actually have 3 deadlines per year, the next one coming up in April, and then July and November. And the expected budget per project is between 500,000 to 3 million euros, depending on the countries involved and the number of partners in the project. Briefly, just to have a quick look at EIT Urban Mobility, the aim of this call is to support SMEs to develop a new product, service, or solution for existing clients, or significantly improve an existing product, service, or solution for expansion into new industry sectors or new geographic areas. The 3 main challenges are future mobility, sustainable city logistics, and mobility and energy. And again, there are recurring deadlines for this track with budgets up to 60,000 euros. So it's quite a smaller budget, but it does add a lot of value to the company when going for non-dilutive funding. Looking at cluster 6, we have EIT food impact as an option, and also raw materials. The EIT food impact funding framework seeks to promote ambitious long-term collaborations that will lead to food systems change to benefit us all. The call has 2 different tracks. The larger scale is the collaborative missions program, and then we have the innovative single project. For the collaborative missions, it has 3 focus areas: improve the impact of diet on obesity and non-communicable disease, reduce food system related environmental harms, deal with threats posed by food integrity and complex supply solution chains. For the single project, the track is for innovative solutions to some of the most urgent challenges in skills, innovation, business creation, and public engagement. And again, this has 3 priority areas: protein diversification, so it's bringing protein into the mainstream. It also looks at regenerative agriculture, so this enables farmers to lead the transition to net zero, and also has a huge focus on labeling, packaging, and transparency, so empowering people in their food choices. This call has 3 yearly deadlines with a budget depending on the track, from 50,000 euros up to 1 million euros, so there's quite a range here. Moving on to EIT raw materials. The Carver Call seeks to advance projects that ensure responsible sourcing, including the precious water resourcing that the mining process requires. So here we have a strong focus on consortia application of 2 to 5 partners. KNL's unique expertise here contributes to various consortia applications. So we have 3 remaining cutoffs for 2025. Now is a very good time to plan ahead for these calls in May, August, and November. And we're still looking at a budget of around 500,000 up to 2.5 million euros. So before I move on to the way that Argentum work, as many of you may already know, as Roberto and Antonello suggested in the introduction, we apply for these funding opportunities through our multi-submission strategy. We've created this multi-submission for companies, research institutes, academia, and this is in order to embrace their innovative R&D. And through our multi-submission, it's really focusing on maximizing chances of success when applying for funding, also looking at reducing the workload during proposal preparation. We also apply for otherwise overlooked funding opportunities. It enables you to leverage partnerships and also increase exposure, but also improve your branding. So what does our multi-submission entail? When Argentum works with a company on grants, we usually work with you for a period of 12 months. The idea is that during these 12 months, we apply to multiple funding opportunities. So we don't just work with you on one opportunity, but we'll work with you on 3 or 4 and many more. To date, we actually work with over 500 funding opportunities in Europe. So our grant strategy is based on an ongoing analysis and identification of these funding opportunities that fit your company's needs, strategies, and R&D plan, along with full proposal preparation and writing of the applications to all relevant submissions. When we do this, it allows us to maximize the options that are available, which in turn naturally increase the chances of securing the funding. It also enables us to leverage the knowledge that we've gained from working with you on one grant in order to submit to more grants and therefore reduce the time and input needed on your side. So part of our service includes what we call our Argentum Consortia link. And I think many of you will understand that partnering and moving together in the European Union to date is an opportunity to succeed. As our multi-submission allows us to target multiple levels of funding, we would look at targeting national funding opportunities as well as any bilateral or intergovernmental grant, along with European funding such as Horizon Europe, which I mentioned before. As we work with over 500 funding opportunities, we can then leverage and dissect these calls, bridging between academia and industry, searching for bilateral calls and European calls, which generally are looking for partnerships or consortia applications. So our Argentum Consortia link is great for companies and different countries looking to work together on collaborative projects as well. So our consortia link basically enables you to join our ecosystem. You'll be receiving support to join EU consortia. As a contributing partner, you'll also receive our support in partner search for your own project applications. But it's not just that, it's also a network building through targeted consortia applications for your own projects and extracting your own added value as a partner in collaborative projects. It also increases your visibility and exposure, and therefore will increase your chances of success. So it gives you the opportunity to, one, lead a small consortium, but also be a significant partner in a large-scale consortia application. The added value of our consortia link, I'll just summarize in a few points, is that basically we want to multiply your possibilities to be awarded. Through our ACL, it dramatically reduces the workload by joining project proposal. You can form collaborations with relevant partners, collaborate with industry and academia leaders. It also improves positioning in the European R&I ecosystem. and enables you to gain access to resources, data, infrastructures, and clients. So I'll just explain briefly a little bit about how we at Argentum go about it and what the business model is in terms of our different teams in Argentum. So when we work with a company, we start off by doing a strategic assessment. This is at the beginning of our collaboration. You'll be assigned a personal strategist from your sector. So in the case of, let's say, the energy sector, or looking in plastics and food and such, the strategist really aims to become very familiar with the company, understand the technology, know what's in the pipeline in terms of your own R&D. And then they'll do the research and come back to you with a comprehensive and detailed list of all the funding opportunities that you could potentially apply for. We'll then review this list together with you. We have our recommendations and you have your preferences, and then we'll translate this list into a submission plan. So we have a plan that's suitable for both sides for the full year on a timeline. So we know which grant we're going to target, and then what the preparation time is and what the requirements are. Once we have this submission plan in place, we begin working with you on writing the grant application and doing the work leading up to the submission. So in general, the grants that we're going to be targeting can range from €100,000 for prizes, awards, and competitions, up to anything between €3 to €4 million for a single entity. And then we have the larger consortia applications, which can be anything up to 70 million. So just to look at a few conclusions and questions for today. There are many bottom-up calls and top-down calls to target in all clusters. As I mentioned, some calls are recalling, so you can see them with 2 or even 3 deadlines per year. This is really beneficial for all companies in order to meet those deadlines, and also makes use of a multi-submission strategy. As we say here, there's no time like the present when it comes to applying for grants. All the projects that you have may be at earlier or later stages, but there will always be an opportunity for you to apply to. And all of you here today, regardless of what stage your project's at, you all have the potential to go on and win various calls to proposal, whether it's through a single application, bilateral call, or through a consortia setting. So I've come to the end of my my time here for this webinar. I hope that I've given you a decent overview of what's out there in non-dilutive funding. I hope it was interesting for you and that it helped to get inspiration for your next funding applications. As you can see, you have my email on the screen, so please feel free to reach out and contact me if you would like to explore any more of these funding opportunities in more detail, and I'd be happy to delve deeper into the options. Thank you very much.
Thanks very much indeed, Lee. I think that your presentation was very, very interesting, and there are a number of points which are worthwhile to be further explored and discussed with you. I would like to remind our speakers if they can please stay within the time frame of the slot. Otherwise, we will have to shorten a little bit of a coffee break, and you will be hated by all the attendees, I'm afraid. Anyhow, let's move to another very interesting, in my opinion, technical presentation, which is the one related to polyethylene furanate as a new clarifier, a new barrier for PET. The presentation will be run by Robert Siegel and Roy Visser. Robert is well known, and he's working with ALPLA as a head of material research and compliance in the recycling division, and specialized in technologies related to polyester, PET materials for stretchable molding and packaging recycling. And Robert joined also the technical committee of EPBP in PETCORE in 2024, and we are very happy that he agreed to join us. Roy Visser is lead the team that is responsible for the R&D of the polymerization process, polymer product development and application, and the development of the fluoro decarboxylic acid-based polymers. Roy has been working for Avantium for more than 8 years and previously worked as an assistant professor at the University of Twente, where he's also obtained his PhD on polymer engineering. Robert, I'll leave you to introduce us to the PEF world.
So I'm doing the presentation now on behalf of Alpla and as a team with Avantium. Basically, Alpla is a global player doing all sorts of packaging, but we are doing a lot of recycling as well. Basically, we are doing something like 30 million bottles per day. So basically, we know what we say about recycling. So basically, PET could be recycled again and again and again, and it would work perfectly fine. Unfortunately, we have a problem that in some of the recycling streams globally, we are finding bottles which are not so good for us. They are making the recycling too dark, too yellow, too hazy. In some cases, we have red dots, black dots, whatever. So we have very, very challenging targets all over the world to succeed with recycling and the recycling content. But we need organizations like EPBP, Recyclas, JRC or SEN to standardize what can be recycled and what is a problem for recycling. So we have to get rid of those bottles which are problematic for recycling. Otherwise, we will not meet the challenging targets of different structures or targets, for example, for the European Union. Some of the bottles out there, if you do a small test, and you can basically do the test on your own, the oven at home, you can heat up to 200 centigrades, and after 30 minutes you can already see very often that a bottle is getting totally yellow. It is getting also totally yellow when we do the recycling. Some of the bottles which are getting yellow are related to barrier bottles. So some oxygen barriers, for example, are getting yellow because they react to this oxygen. At the same time, and that's quite new, there are barrier materials now on the market which are not making the recycling stream intensively yellow, not hazy, and this is quite new. So the Queen of the Netherlands just opened up the Avantium plant in the Netherlands. This is one barrier material which is helping us in the recycling, that the recycling is not getting too much yellow or too much hazy. Alpla is working together with Avantium to boost the barrier of multilayer structures with PEF. At the moment, we are not matching totally well the polyamide, but we are getting better and better and better. We are in the middle of the optimization work, and this is, I would say, a big benefit for the whole European recycling industry. If we now compare the barrier material PEF to other barrier materials like polyamide EVOH or other barrier solutions, we see several advantages which are good to us. Well, one advantage is it's plant-based, it's improving the recyclability, and we have a shelf life extension. So for us, all these advantages are helping us. Basically, the chemistry of the PET is very, very close to the chemistry of the PEF. They are like brothers to each other, and therefore we see some unexpected positive effects. So problem of discoloration of yellowness is one top problem for us. But the other effect, which is especially important for recycling materials, is we don't like that the recycling materials are getting too hazy. And we are doing tests with different barrier materials to see what is making the PET recycling more hazy or less hazy. And here we see a quite interesting effect with PEF. We do not see the haziness we would see with other barrier materials. It was not clear to us from the beginning why all of a sudden other barrier materials are making the PET hazy and the PEF is not making the PET too hazy. And then we found out that the PEF actually is reacting with the PET, and this reaction leads to the situation that the PEF particles in the recycling disappear. You don't see them in the recycled PET. We went even further to that. We were checking if the PEF even could help the recycled PET to get less hazy, and we're seeing quite an interesting effect that the addition of PEF was making our recycling material less hazy, and we typically saw less crystallinity. PET at the moment, as it is on the market, is having already a chemistry inside called EPA, making PET bottles less hazy. So all the bottles on the market are typically, they have something like a clarifier inside called EPA, and the PEF is behaving as EPA and giving us some benefits on the recycling side to reduce the haziness of recycled PET bottles. So when we are now preparing bottles with a recycling content, and at the same time we add the PEF, we see that those bottles are less hazy. So if you look at the picture, you see that 2% or 5% are making the PEF, are making the recycled PET less hazy. The haziness is getting more important for very thick-walled bottles. So thin bottles, they don't fight too much with haziness, but very thick-walled bottles, like refillable bottles, haziness is important there because the wall thickness is so high. And here you see two bottles with and without the clarifier PEF. And you see on the left side a lot more haze with the recycling material in the refillable bottle. PEF is bringing a lot of opportunities for the mechanical recycling, but for sure, each recycling material has to be tested out. Not one region similar to the next region, not one application similar to the next. So this has to, of course, to be tested in detail for the local situation and has to be discussed as well and endorsed from the local structures like EPP and or APR to be okay with the local recycling stream. For us, these are tests which we have done from the beginning, since the last 10 years. But if you go large scale, of course, you need to fine-tune this to the local situation. So looking at the positive effects, if there's now this material available on the market, and if there's a customer demand, we would be willing to offer clarified rPET to the market as a new possibility. I hope I was fast enough, Roberto.
Absolutely, you are superb. Thanks very much indeed, Robert. I think it is very, very interesting, and that tells us that the frontier, we didn't come to the last frontier in terms of discovering new things, how to improve the quality of the recycled PET. And that means that we are, as an industry, we are always ready to take upon us all the challenges and try to find a solution. So thanks very much for your contribution.
Thank you.
Now we move to another interesting paper, which is related to ensuring plastic safety and standards of compliance with quantum software. And the speaker is Melania Gomez. Melania Gomez is a chemist, and she has a master's degree in medicinal chemistry and also a PhD in organic chemistry. She oversees a project focused on sustainable technologies, for the production of high-quality recycled plastics and collaborates in the plastic quality control automation to ensure the safety of industrial applications such as hygiene, cosmetic, and food. Melania, the floor is yours.
Thank you, Roberto, for the introduction. Also, I would like to say good afternoon from my side. So over the next 20 minutes, I would like to discuss with you the need of the recycling industry to ensure the safety and the compliance, and also the reason why we have been working in this quantum software, just trying to help to solve all the challenges that the industry is facing so far. But first of all, just let me introduce the company for those that do not know it yet. So Cadel is a Spanish company located in Alicante, and it was created with the aim to enhance the quality of the recycling plastics. That was the reason why we realized one of the most inconvenient was the presence of the ink. That was the reason why we worked pretty hard to develop the inking technology, which is a water-based process that is able to remove surface printed printed plastic. So we developed the technology, and in 2014 was patented, and we have been sold so far 7 industrial plants all over the world, as you can see in the slide. So in 2021, we sold the technology to EREMA via its auxiliary key cycle. And here it's a portfolio about the different kinds of material that we were able to de-ink. Also, as you can see, car bumpers, for example, are able to remove the ink under our process. And we have a validation plant in our facilities just for those clients that want to validate the inking technology. Since then, we are continuing the same direction. So the company, it's really investing in R&D projects, always trying to enhance the value of the recycling material, just trying to use it in high-value applications such as hygiene, cosmetic, or food industry even. Today, I would like to focus more in the quantum software. So it's a digital tool that we have been working since 2 years already, trying to help to decrease the waiting times, and also trying to help in the decision making when you want to know which is the quality of your recycling plastic, and also in which application you can use it. But first of all, just let me introduce very briefly the storytelling of this product, because if you analyze the different scenarios that appear in the slide, probably the first thing that comes to your mind is, okay, there are different cases that they have nothing in common, but actually all of them, they have something in common, that to make the decision, you always need data. So for example, if you want to buy a house, or you want to know which route is the shortest one, or even if you want to go for a run, then you will check if the weather is good or not to go. So at the end, you always need data, and with this data, you make the decision. So just keeping in mind this approach, we thought, okay, we need to do a similar thing, but in the recycling industry, because data and information is very important to make the decision. And to make the decision, you always need tools, digital tools. And now with artificial intelligence, I mean, you can have the perfect combination in order to have a good information about which is the quality. So then you can decide whether you can introduce your material. So this was the question we make at the beginning. Okay, we can just try to focus this in the recycling industry, and actually yes, because a lot of question is coming to our minds regarding the value of the recycling plastics, the quality, and also the regulation. Because for sure, I think that the industry it's aiming to introduce recycling plastics, but also always keeping in mind the safety net. So, for example, if I'm saying regulation, I guess for most of the audience, the first thing that comes to the mind is the PPWR regulation, because now it's very important to target the different topics that will appear in the regulation, and we need to be prepared to introduce the recycling content that appears in the regulation. But to make the decision, I mean, it's a lot of things that we need to keep in mind, because it's not just the regulation, it's about the contamination of the recycling plastics, the toxicity of the substances that are present, and so on. So as I was commenting at the beginning, sorry, it's important to keep in mind all of these parameters, for sure the regulation, but we need tools to help us to make the decision in the most accurate way. And that's the reason why we have been working so hard, I would say, to develop this software tool, with trying to help in the interpretation of the risk assessment, trying to be aligned with the corresponding regulation on the standard that the company has. And also it will give a very helpful information in order to determine which is the recycling content that you can introduce in your packaging, which will be aligned with the upcoming regulations that are coming in the next years. Also, it will give information about the standards, the quality of the recycling plastics, and also will avoid the fluctuation we have so far in the quality of the recycling materials. Now I would like just to briefly show you a business case, so how the tool works and information you can get. Here's an example of a project that we are working with a converter company that is making film for different applications. So we focus at the beginning in the hygiene products that they are manufacturing, because they had problems in the fluctuation of the quality. So they had a lot of problems during the blown film extrusion. So they needed to get information about which is the most proper way to sort those plastic batches that has not the quality they need for their process. And also they had problems with the interpretation of the data. So if you want to analyze the quality of the recycling plastic, you will get normally a report with a list of substances and concentration values, but you will not have the interpretation behind. So for them, it was complicated to understand all of this and to put this in I would say, a black box. So that was the reason we started working with them, just trying to design a protocol. Because I guess most of you will agree that if you follow the standard regulation, what they are saying is you need to check probably everything. So the substances that appear in the regulations, such as the 10/2011, if we focus in the food content materials, but also you need to analyze the NIA, so those substances that are non-intentionally added. So at the end, what the regulation more or less is saying is you need to analyze everything. And for the production daily life, it's really not possible. So for sure, you need to maintain the safety, but with a protocol that is more suitable for the production line. So in this regard, what we have done so far is to design a protocol in which we were selecting the substances that were interest for the application that the company has, and then we were analyzing those substances every batch. So you want to do a more extensive analysis of the contamination of the plastics. You do it each 6 months or every year. But every week that truck is arriving to the facilities, we were analyzing only the substances that we were pre-selecting. And this is what you get. So you get a comparison about the different quality of the different batches that we're analyzing over time. The good thing of the tool is that you have a historic or a data record where you are accumulating all the information of the different materials that you are analyzing, and you have information about the toxicological information of the plastics and the recycling content you can introduce. Here is another example. As you can see here, well, I have not a laser pointed, but you can see the one that is square in red. So this is the material that we are comparing regarding the others. So as far as this material, means that the properties are less similar comparing with your reference. So it's a good way when you have a lot of data to filter what we call a safe area. So the area, well, the material that comes around this area, it's safe to be used for those applications. Here is the new PDF file that we have uploaded in the software. When you have more clear green or red, the substances that are above or below the limits, with all the toxicological information that appears in ECA and REACH. So it gives you information about the recycling content you can introduce in your packaging. For sure, always, it's a tailor-made software. So we so far have introduced the 10/2011 for food content materials, but also we are working just to introduce the standard protocols that the company has for their process. And this is the last thing I would like to present, and I think I still have some minutes left. So what I was presenting so far, it's a tool that helps you to make the decision, just trying to interpret it and compare all the data. But at the end, you need to generate this data, which also take time. So we were thinking that also using artificial intelligence, we can just try to combine data with images, just trying to get the same information. Because if we are able to do so, then we will be much more faster in generating the data. So then we can be more faster also to make the decision, which is going to be very good for the facilities or for the production. Here, I would like just to show you some examples. Well, this is just a scheme about how this works. So the first thing that we plan is trying to be able to classify the different sorts of recycling plastics just by taking an image. So we have been done different trials about the way to make this picture. Then we make a kind of conversion of the image into what we call the data that is fitting into the training models. So then we select the algorithm that works the best, and then we get just the result and make the validation. Here, I will just show you two examples. This one, it's about determining the recycling content, which is going to be very good for the PPWR regulation. So in the confusion matrix, I will not go into detail, but this is our way to determine the accuracy of our measurement. So in the recycling content, we are over 70% accuracy. And yeah, we are still working, trying to enhance the accuracy, because the problem of these kind of systems is like always, so to train the the IA, you need a lot of data. So that's the reason why we are working introducing much more data to be more accurate. But also we are not stopping there. So we also want to try to differentiate the different sorts of the recycling plastics. So here the accuracy is not really good. So we are over around 30% accuracy, because for the system it's a bit complicated to differentiate those batches that has the quality that you standardize at the beginning. But I mean, for sure we are still working on that, and I think we will make a good result. And this is the last thing I would like to present. So also we are planning to trying to determine the contamination just by an image. And here is just a brief example about how we were able to differentiate just by taking an image about virgin LDPE with and without additives. So one of the components that are present in this material is erucamide, and we were able to classify and to differentiate the different material just by an image. So now we are trying just to make the calibration curve, trying to quantify the amount of substances that is in the plastic just by taking the picture. And then when all the process is performed, then we will try just to add new substances, trying to see if we are able to quantify them just by picture. With this, I conclude the presentation. So basically with this software, what we try to do is trying to help the recycling industry, just trying to get more information about the quality, and also trying to help in the decision making about where and in which application you can use it. So this is just the demo. So I think you will get the presentation afterwards, so you can just see how the system works. We will have the last update, the new version, I think, in 2 weeks. So yeah, if you have any question, please do not hesitate to contact us.
Thank you very much, Melania. I think your presentation was very interesting, because also the way that you wanted to link your technology with the artificial intelligence, in my opinion, is triggering my curiosity, because of course you say with the artificial intelligence applied to your technology or to your tool, then you should be able to, in a way, predict the quality of the recycled plastic. So that's something which I think the industry will certainly welcome. Okay, thanks very much. Now, I think that we are open for question and answers. I don't see question and answers coming through the question and answer session, so I don't see anyone writing questions, but of course, I mean, we are also open for direct questions which could come from the audience. So if anyone wishes to break the ice and put a question, more than welcome. I think that you can do it by raising your hand, and Maria and Edward, if I'm missing some raised hands, just help me to spot them. At the same time, I also believe that being these presentation very technical in a way, it may require some time for the audience to go through them, get accustomed to what it has been presented, and then to elaborate some questions. There is one, two, okay, they are coming. Okay, what's the minimum percentage of contamination in the PRC containing material that the system can recognize? I think that this one is probably for you, Melania.
Yeah, no. So I guess you mean for the image recognition part, right?
I
I
think
guess.
so.
I don't know.
I
Yeah.
think so.
So at least what we know so far is we are able to differentiate the virgin with and without additives. For example, more focus on in the erucamide. The one that we have been used has 3% of erucamide. So if I'm not mistaken, it's around 30,000 ppm. So I would say the limit for sure now it's a bit high for sure. So this is the first, how do you say, the first trial that we have performed so far, just to see we are able to differentiate. And then since then, we will try to write the calibration code, trying to see if we are able to quantify the easiest scenario, and then we will try to decrease the limits. So for sure, we are not going to reach, if that's the question, the analytical analysis by GC or LCMS. That for sure not. So the approach that we have so far is to filter. I mean, to filter those batches that have the quality that you need for your system from the others. So in some point, depending on the application, on depending the specification you will need or the detection limits, you will need to go for this analytical, more specified apparatus. But we believe that this way to sort is going to be much more easy to integrate in a industrial plant, for example. So
Okay.
I hope I'm answering the question.
Well, thank you. Thank you for sure. Let me just go to the next one, which is, do you have experience from PET laminates with aluminum layers? Again, I would think that it is addressed to you again, Melania, because it's...
Yeah, I think so. Probably this is for the denking technology, right? I guess. So we tried years ago to delaminate under the denking technology, but it was not working properly. So to remove aluminum, it's possible. But to separate different multi-layer packaging, we didn't succeed. But it's true that if you want to know more about the tanking technology and about if it's able to separate or to remove any coating, I would say please just contact KeyCycle, and also you can email me and I can facilitate the contact information, so then you can have more precise information about the technology and also if it's able to work and with the material that you want to try.
Okay, very good, Melanie. And there is a question from Bruno, and the question is for PEF, polyethylene furanate. So it's for you, Robert and Roy. Question: have you done some work on how PEF will perform when recycling by depolymerizing PET-containing PEF layers? So it has to do with multi-layer containing PEF and the performance of PEF when it is recycled by depolymerization.
Shall I take this one, Robert?
Roy,
Yeah.
you take this.
Yes, I can do so.
Great.
So yes, we have done work on that, mainly on lab scale at this moment still, as real large scale is not yet so available on this work. But what we of course have done is first checking, okay, what is the difference between depolymerizing PEF compared to PET on glycolysis, methanolysis, hydrolysis, all those different environments, so to say. So from that and comparing that with PET, we already know a bit, okay, how can they go in one system? The next step on seeing, okay, how does it really go into a real actual system? That's a step we still need to take to see how it works in equipment of people that really are developing the depolymerization technology, because how it will actually run in that technology really depends on the technology itself, right? So not only on the depolymerization step, but also on the step after, on the purification step, what follows after. So there we really are looking into, okay, with which partners can we collaborate and where can we further develop it with.
Thank you, Roy.
You're welcome.
I think that, depolymerization is an important, way of looking at opportunities and those areas where we stumble into difficult to recycle, mechanical recycle stuff, which could be, say, package containers, textiles. So there, indeed, depolymerization could play a major role, and clearly, new innovative solution which are representing certainly opportunities. At the same time, they might represent also challenges. But that's why it is important that companies like yours will be able to have a dialogue with some of our companies which are instead involved in depolymerization technologies.
Yeah.
Thanks for the contribution. Then there is one question from Nitya, and it's for Lee. I'm curious about the EIC Pathfinder funding opportunity. You mentioned 3 partners are located in at least 3 different countries. These partners all need to be SMEs, so small, medium-sized enterprises, or could be 1 SME and 2 research institutes located in 3 different countries.
Thank you, Nithya. Yes, so it doesn't need to be all SMEs. It can be a range of SMEs, research institutes, academia, as long as it's through 3 different countries, as long as they're EU countries, and also those associated countries from Horizon Europe as well.
Very good. I don't see any other questions, but I have a curiosity for you, Lee. I was just wondering whether, for instance, you have been talking about a number of opportunities to search for fundings, and very much so you said we need to be fully embedded in what you do, what you want to achieve, the market you are operating in order for your company to understand the best ways to look for fundings. And also the multiple solutions that you were presenting is very interesting. But when you come to, for instance, an association like a PETCORE, PETCORE is a value chain association. So we are not just representing one sector of the PET industry, but we tend to represent the whole PET value chain. Now, in that case, of course, there are projects which are of interest to the whole value chain. So do you think that you could do the evaluation that you explained working with PETCORE Europe in such a way that if we identify areas where we would need funds to carry on specific research of interest to the whole value chain, then your company could support that type of project?
Yes, definitely. Thank you, Roberto, for that question. Yes, it doesn't necessarily need to be an SME or an academia or a research institute. It can be large enterprises as well. As long as the company themselves have R&D for specific projects, then of course anything and everybody is welcome to apply for non-dilutive funding. The way that we would work with a company like PETCORE is that we would first of all do a strategic analysis where we want to analyze together which projects are the most imminent for you, what's part of your strategy. And from there, we'll be able to take each project individually and find the specific calls per project. Absolutely.
Thanks very much indeed. Thank you. I'm just looking at the screen to see if there are more questions coming up. We are ahead of time, so I have been too negative in the beginning, and sorry for that, but you did great. So I think that maybe we can go for a coffee break. The coffee break was for, say, 15 minutes. If we start now, we can get together in, say, by 3:25, something like that. Okay, so let's go for a coffee break and see you in a little while. Thank you.
of this slide. However, UPM is just being rebranded as a material company. So we're going away from the focus on paper alone, and we start to look into different materials. As you see on the right side, UPM Biorefining is the business unit comprising two interesting new companies, and new, I must say, in the case of UPM Biofuels, is not so new anymore. It's already 10 years operating in converting tall oil from Nordic paper production side stream into biodiesel and bionafta. And this is actually the key element to solve the PTA sourcing here in Europe for wood-based PTA. I will tell you a little bit about later. And then the, let's say, lighthouse project UPM Biochemicals, which is the first of its kind biorefinery that we have just built and are launching right now in Germany to produce MEG based on wood. Let's first look into that. UPM Biochemicals in the small town of Leuna is actually close to Leipzig, which you see on the map on the right side here. This is the biggest chemical park in Germany from the size, the sheer size of it. Of course, it's not as densely populated as the BASF site, but it has been traditionally the chemical side of East Germany. We have invested the immense amount of 1.3 billion euros into this 22 football field size biorefinery. So we are not talking about pilot scale or demonstrator or whatever. We're going really big now. The task here is to convert 100% wood-based chemicals. The total capacity of this factory is 220,000 tons of various different chemicals, which I will show you on the next slide. The ramp up has already started. We're ramping up sequentially since January 2025, and we will have first commercial volumes in the second half of this year. This is the, let's say, most technical slide I will show you today. I will, however, simplify very much. On the left side, you see a typical beech tree example. So we're using beech tree, and we can use 98.5% of the wood material coming into our factory because we can only not convert the bark of the tree, which is 1.5%. Anything else, cellulose, hemicellulose, lignin, is converted into various chemicals. To make it simple, the cellulosic part, 45% roughly, is converted into the glycols on the right side. The hemicellulose is converted into the industrial sugar in the center bottom side. And then the lignin part, which is roughly 20%, is converted into the so-called renewable functional filler, which is a carbon black replacement, also very interesting for black pigment application, also precipitated silica replacement in all types of polymers and rubbers. It is NIR detectable, by the way, and carbon negative in its cradle-to-gate footprint. Same as the glycols are carbon negative in a cradle-to-gate approach in their footprint. We use a different process than the petrochemical process. It's a direct wood to sugar and then sugar to glycols process via enzymatic hydrolysis and then a catalytic conversion and distillation. So there's no ethanol involved, ethylene oxide, and so on. This is a streamlined process that is much more efficient. Okay, now to our raw material, wood, which is the reason why we are, working the market on a pull strategy. We talk to the brand owners to create an interest for this product because the petrochemical value chain of the typical PET production value chain is not accustomed to speak about, how you say, certified wood material and forestry. But it's very interesting or important to understand how forest material can actually be sourced in a sustainable way. Our factory in Leuna is using forest material really locally sourced around our factory. We are focusing on the beech tree because it's the dominant hardwood tree in this type of forest in the Central European mixed forest areas. It's growing actually, its share. So it's in the future being more abundantly available. And we use 100% certified wood. That is implying that any wood that we will use has been taken out of the forest in a sustainable way. So there's no deforestation at all in our supply chain. And wood material is a true second generation feedstock that is as such renewable. So it's not a waste stream, it's really growing as such and being a second generation feedstock. We don't use the, let's say, nice and beautiful parts of a tree that would go into the furniture industry. So there's no, let's say, forest harvesting for us. We use the residue streams, that is basically the crown material of the tree, branches that are not big and nice enough to go into furniture industry and that are mostly dedicated to burning today. So 70% of this so-called industrial wood is going into the firewood or pellet industry. And we are convinced that we can give this material a second chance before its end of life, so to say, to go directly into CO2 burning, to create, a use as packaging or textiles or even cooling agents for automobile use. The idea behind this is same as with any bio-based material, the renewable carbon cycle of biogenic carbon capturing. So the wood material is the trees, the forest material is capturing the CO2 from the atmosphere. And we convert the carbon inside of this material into drop-in chemicals that can then go into the existing supply chain of the PET value chain. The products, the packaging, whatever is produced will then have its lifetime and recycling cycles, etc. And at the end of life, when it will be eventually burned, the CO2 is returned back to the atmosphere. So it's a closed cycle, no enrichment of the atmosphere with fossil petrochemical CO2. Now this was the MEG part. Now let's go to the 100% bio-PET solution that UPM is proposing now to the market. We have basically worked on two offers to the market. One is and I've given some examples here from the Coca-Cola marketing, let's say. Option one is the 30% plant bottle, so to say, 30% biomag, 70% fossil PTA. That is, let's say, part of the history now. This is, of course, still available. Some customers actually prefer that. And then there's option two, 100% bio-PET with eventually a net zero carbon footprint. This is 30% biomag plus 70% mass balance bio-PTA, which we will obtain by joining forces with our colleagues at UPM Biofuels in Finland. The exact layout of this value chain you can see here. So on the top level, you see the Leuna operations, where at the top right, we will get the bio-MEG with the carbon negative cradle to gate footprint directly with 100% bio content going into the PET production. In the middle of this screen, you can see the softwood supply chain that is going into the paper industry. So our own pulp mills in Finland produce wood pulp, paper pulp, and there's a side stream of tall oil, which historically has been burned to generate energy. Now, our colleagues at UPM Biofuels, since 10 years already, since 2015, they convert this into biodiesel and bionaphtha. This bionaphtha leaving our Finland operation is also 100% bio-based. However, we need partners to convert this into terephthalic acid and therefore have to rely on the petrochemical supply chain here. This is where mass balance and ISCC Plus certification comes into place, into the game, and then the bio-PTA produced by our partners will go into the PET production of companies the like of Indorama, Plastipak, Selenis, to just name a few that would enable a European supply chain. Of course, we can also and do also work with Asian partners. Now to the carbon footprint of that. This is an carbon footprint modulation of EcoInvent 3.10 This is including the biogenic carbon uptake of 2.3 tons per 1 ton of PET produced with our raw material. Then we have emissions of the terephthalic acid production and the MEG, where you see that the MEG emissions are very, very little due to our improved process. Polymerization is also not strong on the emissions, and then we reach a carbon slightly negative, let's call it even net zero footprint. And that is the offering to the market that UPM is providing here. In terms of mass balance, I don't want to go too much into the detail here. This is more on a customer orientation where you need to kind of explain mass balance. Everybody here, I guess, knows how it works. We like to compare it to the electricity market where you buy green electricity knowing that there will not be any green electricity really reaching your home, but you are supporting and fostering the industry to transition to green on the long run. In terms of supply chain, as I said, I already given some names. BioMEG and BioPTA is what we organize in the market. Then we work with partners the likes of Selenis, Indorama, Plastipack, to just name a few. The important message is here that this is going into your or your customers' existing supply chain. No need to change the packaging converters or whoever, not even to change the machine running times or whatever. It's really a true fossil counterpart or alternative. We have already done hundreds of trials. Those are just 4 of them. We have used the MEG on the left side in polyurethane shoe soles for Nike. Then you see the mineral water bottle that I've just shown you. We have done fleece pullovers with Vaudi and the Bormioli Pharma bottles. So we have more than 250 approvals in the industry today, proving that we're a true drop-in chemical. And there I am at the end. Let's hop on the sustainability train together. Looking forward to your questions and comments.
Thanks very much indeed, Nico. I think it is very interesting. And yes, I mean, sustainability doesn't go down the road on one way only, but there are different paths to be taken. And then it's interesting to look at yours as well. Then I will move to one more interesting paper, which is the one related to the testing methods and risk assessment of NIAS in food contact and cosmetic application. This time I will not spoil anything of the presentation, I swear. So it will be really a great surprise. I will say a few words on the speaker, Lisa Filindassi. Lisa was born in Florence, and she began her career as a microbiological laboratory technician in a pharmaceutical company. And then after years of spending quality control laboratories analyzing the most disparate matrices, she developed herself to the study of materials and objects intended to come into contact with food, and over time becoming a reference figure for companies in the panorama of experts in materials and objects in contact with food, matching regulatory and technical requirements on a global basis. So the floor is yours, Lisa, and we will listen to your presentation.
Thank you very much, Roberto. And okay, can I move slides here? Okay. Nothing in regards of the title of my presentation, because we will move towards NIAS screenings and the overview and escape of chemicals, chemical contaminations into the food into food and packaging due to the materials used to pack them. Couple of words about our companies. We have a delay. Our companies, I am speaking on behalf of 2 companies actually. Food Contact Center is the laboratory. Is mainly made of 3 main sites. The bigger one is here. It's Serravalle Pistoiese where I'm speaking. Then we have another laboratory in Brescia and an R&D pilot plant to make challenge tests, to evaluate the effectiveness of recycled materials. A couple of years ago, from a RIB of Food Contact Center, which was aimed to make consultancy to companies, was born Food Contact Services with the only duty to offer consultancy and trainings to companies, offering together with the Food Contact Center a 360 degrees service. In Food Contact Services, we developed also tools to help companies in finding the compliance. You can see, I don't know if you can see my mouse, but it's the same, but the right bottom, you can see two QR codes, and they are videos related to the tools which I mentioned before. One is regulatory compliance tool, and the other one is for labeling. So matching compliance based on chemical compliance and sustainability. Okay, who am I? I can skip totally this slide. Moving toward the agenda, we will have a look to the chemical landscape of chemical substances in our world, how to evaluate the risk assessment, how to perform a risk assessment, how challenge tests are developed, and two case history, one for PET and the other one for PP. Any one of you knows what are food contact materials? Just to recap it, food contact materials are all the materials and objects intended to be brought in contact with direct and indirect contact with food. Food Contact Center has been involved in the analysis of food contact materials for years, even before it's born. And recently, cosmetic packaging is has been evaluated using the rules used for food contact materials. At the European level, we have Cosmetics Europe that is developing a guideline called COSPATOX for the use of recycled material in contact with cosmetic products. But we will speak about it later, just a couple of words about it because it's not yet issued. We have more than 5 million known chemicals made by humans, artificial chemicals, and 80,000 are commonly used. So in laboratory, we have to face all this huge amount of chemistry to be evaluated because of their toxicity and the risk that can provoke to human health. How? Through migration into food or cosmetics. You have to forgive me if I will speak mainly about food because okay, food contact materials are really well known, and while cosmetic materials, cosmetic packaging is not so famous, but consider them like more or less the same. Anyways, how can a substance contained in a packaging can migrate, can disturb the food packed inside? Through migration. Migration can occur in indirect or in indirect way through leaching, permeation, or volatilization. The factors that can influence the migration are the condition of use, so time and temperature. Of course, increasing time or temperature, the migration will increase because of Arrhenius principle, and the composition of the material in contact with the food, the cosmetic, is as well important because there are materials like glass which are not intended to let anything migrate into the food, more or less, and other materials like plastics, unfortunately, which can lead some migration. Okay, so we have direct contact, we have a gas phase migration, we have a penetration migration. Which are the differences? Direct contact is easy. So the packaging is in contact with the food, and in the interface between the packaging and the food, we can have the migration based on the different solubility of the substance in the packaging or in the food. The gas phase occurs when volatile substance can go into the food when the temperature let it volatilize, and okay, in that case. Penetration is when a substance used in the external surface can go through all the plastic, all the barrier, arriving to the food. Oh, sorry, I have problems with this. How to evaluate substances? Generally speaking, our regulation regulates IACs, so substances intentionally added to the formulation of plastic materials. The intentionally added substances are all those substances listed in the Annex 1 and 2 of the Regulation 10/2011. The Article 19 of Regulation 10 asks also for the verification of NIACs. NIACs are all the substances not intentionally added, which are claimed also by Article 3 of Regulation 1935, and which can be identified as impurities, newly formed products, degradation products coming from degradation processes, by monomers or additives, or the use of recycled materials. So all these processes or these kind of sources can provide to a material different kind of contaminants, unknown contaminants, that can damage the human health if they aren't checked and verified. How to be sure that food contact material is not dangerous for human health? We have to produce a risk assessment. Risk assessment is composed by 3 phases: the hazard identification and characterization. So we have to understand which kind of substance or substances we have to evaluate for their quantity. We have to evaluate the exposure. So after the evaluation of the quantity through a target analysis with the same standard as the substance, or an internal standard, we have to evaluate the quantity and the possibility for a human being to be in contact with the substance, considering also the exposure, the way of exposure, and the quantity of the specific food injected by every single person each day of its life. In this point, I would like to underline that Cospatox, for the first time, is giving us, luckily, a different way to understand the exposure path for cosmetics. So until now, we used the limits provided by food regulations also to understand the dangerousness of migration into a cosmetic article. So if I have a cream to be put on my skin, my exposure could be 1 kilo per day, and considering the toxicity had by injection. Cospatox released as a list of substances derived from cosmetic packaging and their toxicity, considering the dermic toxicity and inhalation toxicity. Okay, combining the hazard identification and characterization and exposure assessment, we can arrive to risk characterization, estimating the likelihood of harm occurring for every human being. Why we are proposing and we are promoting untargeted screening? Exactly for this reason, because it's easy to keep under control ISs, so substances intentionally added, by manufacturers, because each manufacturer knows exactly the quantity of substance that put into the formulation, but they probably don't know how a granule or flakes or something can be treated by the other actor of the supply chain, by their customer, and so how the granules can be melted to produce plastic film or plastic container, and which other substances can include. With untargeted screenings, we can verify the known contaminants and also the unknown contaminants, giving them a risk a risk assessment, so a risk characterization based on the detection and the identification and the quantification using an internal standard. So it's useful also to monitor the GMP system of each company, each manufacturing process. This is a little scheme about NIAS screening. After years of study and development of techniques, we accredited finally the LCMS screening. Our LCMS screening LCMS is able to detect also substances not visible using GCMS. So due to their molecular weight, if you can see in the X line, and due to the hydrophilic characteristic of each substance. So using only headspace and GCMS, we risk to be blind for some contaminants. This is another particularity of LC screening. So while for GC we have a NIST library which is sold together with all the instruments and developed after years and years and years and years of developments with different suppliers of instruments, for LC we don't have such kind of library, because the identification using LC depends on the geometry of the different phases of the instruments, and also by the element used. So we developed the library consisting of about 15,000 compounds only related to packaging, and the other NIASs including in the EPA list. It's an added value because, of course, we can see also unknowns deriving from polar and high molecular weight substances. Why we can be so sure that our identification is good? Because the identification using LC is double. We can identify a substance using the fragmentation mass, and also with the molecular weight, the precise the exact mass with the 4 decimal figures for molecular weight. Combining those the two results, we can have more or less an exact identification and structural formula. We analyzed a lot of materials during years, both plastic, paper, and paperboard, finding only more or less 700 compounds, 500 coming from plastic and 230 coming from paper and board. So not so many comparing to unknown, comparing to the lots of chemicals used in industries in general. The main part of migrating substances coming from plastic materials are from the phthalates, are bisphenols, are primary aromatic amines, UV absorber, and they are more or less always the same. So let's make some case histories. I prepared an overview of the challenge test for recycled polyolefins as an example of all of the challenge tests for usable for all these materials which don't have a standardized test method for challenge tests, because any one of you knows that for PET we have some rules to check the effectiveness of a recycle process, while for polyolefins, polyamides, polystyrenes, blah, 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 we don't have them. And it's caused by the so different kinds of materials related to the same class. Our approach is to verify okay, the effectiveness of the recycling process, considering that we have to choose at first the kind of surrogates to be used to contaminate the plastic flakes, and then to verify the decontamination process after the recycling. So the surrogates used in the case of polyolefins were like antioxidants, bisphenols, benzophenone, chlorobenzene, toluene, and hexane. So also substances with high molecular weight, higher, of course, than the ones used for PET. And how the challenge test is done. At first, we have to verify the effectiveness of the contamination in a laboratory. So using a pilot scale with a becher and grams of flakes and grams of surrogates, extracting surrogates, we verify how much I have contaminated my object. And then we verified the effectiveness of this contamination in, sorry, this is the instrument, the effectiveness of the contamination in a tumbler located in the R&D pilot plant. Here you have a chart of the contamination. And then we ship the sample to the customer who recycled the material, produced the flakes or other granules, and send us back to verify the concentration of the surrogates at the end. For rPET, we evaluated the same. We found some strange peaks. This one with ion 136, which could be linked to benzothiazolic acid. After the choice of some derivatives of phenylurea and the analysis of the other peaks presence, we understood that this peak could be identified as one of the two substances below, so 1,2-benzothiazole 3-YL 1,1-dimethylurea, 1,2-benzothiazole 3-YL 3-ethylurea. For polypropylene, instead, we did the same, finding in headspace, of course, when we have to verify the effectiveness of contamination and decontamination, we coupled all the techniques. So we use headspace, GCMS, and LCMS, of course. In that case, we found acetaldehyde and ethanol using headspace, of course, and other substances like linear hydrocarbons. With HPLC Q-SOF, we found a derivative of PA6, which was also proved by an article in literature, so we were confident about the result we achieved. Those two examples were only to let you understand how our laboratory could set up a method according to the real customer needs and the real customer products and projects. I think that's all. Yes, thank you for your attention. I'll be waiting for your questions and comments. Thank you.
Thanks very much indeed, Elisa, for driving us through, say, the NIOS, not only for the food, but also the cosmetic. And by the way, you know, cosmetic packages, when it comes to PET, at the end of the day, they fall within the same collection channel. So it's important indeed also to identify those NIOS which are there, because ultimately and eventually they will end up in the same stream. So very, very interesting indeed. So let's move then to the last presentation for today, which is also one more interesting argument. And it has to do with, say, the Kerio Packaging Company, material efficiency as a pathway towards a price competitive sustainability. And it will be introduced and presented by Tanguy van der Delst. And Tanguy is a lawyer by training, and before starting Kerio, he worked in public affairs for leading fast-moving consumer goods and packaging groups in Brussels and Geneva, focusing on sustainability and packaging regulation. Tanguy will discuss how materials efficiency can be a pathway towards a price competitive sustainability. And he will explore how Kerio's innovative polymer processing technology enhances material performance, which reduces both environmental impact and manufacturing cost. Kerio Packaging offers a scalable, low-cost solution that can be integrated into existing production assets, making it an exciting development in the pursuit of sustainable and cost-efficient packaging solution. By the way, and that's a very interesting information which I just got today. If you question yourself what Keiro means, comes from the Japanese word for less weight, which is very appropriate, I should say. Tanguy, please drive us through the presentation.
Yes, well, thank you, Roberto. Thank you for the introduction. As you mentioned in the introduction, I am a lawyer, so I can take no credit for the technology that we developed, but I do take credit for the name, because we had to find a way to explain in a simple way, you know, what we were doing, which is basically generating materials efficiency. And if you have an efficient material, you can use less of it. And then we thought that Kerio, a Japanese word, was an interesting way to reference what we were doing. So let me start with our presentation, Kerio Packaging. Just for the clarity, I will start with what we're not. We are not developing a new material. We are not developing an additive. We are developing a processing technology that increases the performance of polymers. And that's what allows us to claim that our technology allows to reduce the environmental footprint, but also the manufacturing cost of plastic packaging. And if you look at the big picture of what we are seeking to create, the founders, including myself, and the funders of Kerio Packaging all have a background in the fast-moving consumer goods industry, more specifically in one company called AB InBev. And as you know him, Roberto Johan, the CEO of our company, was head of packaging innovation at AB InBev a while ago, when there was a big push to develop PET for beer, not for Western Europe, but for other markets. And from that perspective of being, you know, responsible for the innovation for a large FMCG company, he made this global perception that, you know, if you want to have a relevant sustainable innovation, you need to square a few challenges. First of all, you need a technology that reduces the carbon footprint, that increases the sustainability, we all know that, but also that is cost efficient, because cost is a very important dimension in our supply chain. And if you really want to have impact, you also need to do something that can be scalable. And to meet these criteria, well, he said, like, you know, maybe it would be better if you were in a position to leverage existing infrastructure that would address the challenge of CapEx. That is, you also have to be mindful of the technological complexity, but also of the regulatory complexity. And I think the people at PETCORE know very well how much regulatory complexity there is. So if you can avoid that, that's also, that would be a good driver for the innovation, and ideally a solution that can apply to multiple categories of polymers. If you take all these challenges, he came with the what if question, and his what if was, well, what if the slide would change faster? That would be a good what if. And the second what if there was a process allowed to extract more performance out of existing polymers? That would, if I go back to my previous slide, allow to use the existing infrastructure. You would not have to go to new regulatory validations. And because you have more performance, you are likely to have something that is cheaper and that is scalable. And nature tells us something very simple, is that the performance of a material is defined by its morphology, the balance between crystalline and amorphous materials and how they are organized. And nature also gives a very good example of what that actually means. If you look at the molecule of carbon, if you have carbon with a low level of molecular organization, you have coal. If you have the same carbon with a high degree of molecular organization, you have a diamond, which is better when you are in the market for an engagement ring. But fundamentally, it is the same material. What we have done is that we have taken this principle and we have used it to convert the level of organization of polymers. It's a processing tool, and during the processing phase, the polymer is pushed through our device. And what will happen is that the low level of organization will be transformed to a higher level of organization, meaning a different structure of crystals, a different way the amorphous components are organized. And this technology is based on a well-established science, which is called the science of flow-enhanced nucleation and induced crystallization. And this science tells you that there is an ability of polymers to alter their crystallization kinetics and the resulting microstructures when they are subjected to deformational flows. Now, I just want to open a caveat here. When we talk about crystallization, we've seen that there is often a misunderstanding, because crystallization is not always seen as a positive development in industrial processing. And there is a clear difference that needs to be understood between the best known crystallization, which is quiescent crystallization, and the crystallization that we leverage, which is flow-enhanced nucleation and induced crystallization. If you have some time, go check on our website. Our colleague Edita Niemczyk made a very comprehensive paper that explains the difference between the two sources of crystallization. With flow-enhanced nucleation and induced crystallization, what you do is that you control the flow to stretch and align the polymer chains to create a more uniformly spread nucleation and generate crystalline structures that are smaller, better oriented, and better integrated in the polymer matrix. Whereas when you have quiescent crystallization, you have spot-like places of crystals that are not what you are seeking to achieve. What we have done is that today we have demonstrated that we can apply this process to the field of the PET injection stretch blow molding of bottles. And if you look at the performance of a PET bottle, you're looking at mainly three buckets, which is the top load, the barrier properties, and the thermal resistance. And the amount of material that you will use will be defined by the level of performance that you have to achieve on these three items. Today in our development, we have demonstrated that using a similar type of resin and on standard machinery, we can improve the thermal resistance of the blown article. And we can also improve the various barrier properties, whether it's oxygen, water vapor, or CO2. The way this materializes, if you put it under a microscope, what you have here is, if you have the current process, you have on the picture, you see this represents the morphological structure of a PET bottle. The blue rounds are crystals. And in the current process, you have crystals of a certain size that will define the passage that molecules of oxygen and CO2 and water will travel to go through the membrane. When you use the carrier technology to inject the preforms, and then when you blow the bottles, you will see that the size and the amount of the crystals has changed. We have more crystals of a smaller size, and that kind of creates a more difficult passage for the various molecules. It's like a fishnet. You know, if you have a fishnet and you reduce the size of the mazes, it becomes much harder for the molecules to pass through. And that's how you improve the performance of the material. I will explain you first how we managed to observe this, because this was in itself a challenge. Yes, so to measure this change in morphology, which leads to an increase of performance, we had to develop various evaluation protocols. As a way of an anecdote, I can tell you that a couple of years ago, we shared our technology with a major FMCG that used our technology to inject carbonated soft drink bottles, and they measured a barrier improvement of the CO2 of 15%, 1.5, and they said, oh, we could lightweight the bottles by the same amount. But they didn't see any change in the morphology of the material. So they were very puzzled about how we got about this, and rightly so. So we had to develop, next to measurements that are optical and thermal, we also developed protocols that are based on a nuclear magnetic resonance to define the size of the crystals, and also about X-rays to identify the orientation of the amorphous material. And that allows us to have a picture, what we call the picture of the beast, which is basically seeing that, you know, when we use our technology, the morphology and the level of organization of the material is changed. We also obviously measured the performance, and for the sake of the presentation, I will go fast of that. But basically what we do is that we benchmark preforms that are bottles that are made of preforms that are injected without our technology on the same machine, on the same resin, and then we inject with our inserts, and we compare the difference, and we see an uptick in the various barrier performance, whether it's water vapor transmission, the oxygen rate transmission. Everything is done at the University of Hasselt, that has the right tool set to do these evaluations, but also of the thermal resistance. And what we've seen is that using our technology, you get thermal performance for a generic resin that is quite similar to what specialty resins are achieving. What this leads to is, if you have an increased performance that is yielded by a better morphology, it unlocks two ways to create value. Either if you want to maintain the same level of performance, you will be able to achieve it using less material. And so that will allow you to have, for each bottle, less CO2, better circle of better footprint, but also a reduced use of raw material, which is thereby a cost saving. Or you can have the same amount of material, and then you will have better functional performance, which can impact the shelf life of your product if that is what you are seeking. But there are basically two pathways. Now, what we have achieved and what I just demonstrated so far is not the result of a test in the lab. This is the result of trials that have been executed in an industrial environment. On the picture here, you see the picture of the actual site where we are doing our trials, which is the factory of PDG Plastic, which you might know. PDG is a French preform and bottle manufacturer that's based south of Paris, and we have been working with them now for a couple of years. And when we do our injection cycles, we use commercial grade resin, whether it's virgin or recycled. We do our trials on their standard machinery and within the remits of what the machines is supposed to do, and the machines are operated by their people. We add QCs because we are in a development phase, but the aim there is to demonstrate that this technology can work in an industrial environment, that it is not changing the conditions of the machinery, that it's not impacting the production cycle. The only component that we actually change is that we retrofit a 3D printed insert, and there you have a picture of one of our older models, into the hot runner of the machinery. It is a 3D printed insert. What does it mean? Is that we can design it exactly to fit different types of hot runners. And because it is 3D printed, it's fairly cheap to manufacture. Today, in the small numbers of preforms that we produce for trials, we are under 200 euros for a preform. If you scale that up, you will have much lower prices. And that allows us to claim that this is a technology that is intrinsically low cost, and also that can have a global rollout. Why? Because if it works on one machinery, it can, at PDG, it can work in machines in Milano, in South America, wherever you want. We all know that the types of machineries that are used to manufacture inserts, preforms, are fairly similar. It's also a low capex because we, as a company, do not need to build a production facility. Today, the 3D printing industry that exists in the world has the capacity to produce enough of these inserts for the whole PET, ESBM industry worldwide. So it's a no capex for us, but it's no capex for our customers. The fact that we are, and well, I'm getting ahead. Just I wanted to summarize what I've said here. So today we are not market ready, but we have demonstrated that this technology is validated in an industrial setting. And what we do is that we multiply the validation points to get to a commercial level, and the validation points go about the validation of the platform and the validation of the performance. The trials at PDG, we first did trials at the monocavity machinery because they wanted to be sure that we were not damaging their machines. Once they were confident enough that this was working, we moved to multicavity. But also we've demonstrated that our inserts can process the standard resins that are being used on the market. We have already done more than several 100,000 shots, so we know that the inserts that we use have the right longevity and they maintain their performance over a long period of time. And in Q2 of this year, we will start doing what we call bespoke trials, is that we will start doing testing on bottles that are currently in the market and used by one of our clients that is interested in knowing, how this technology will work specifically for some of their packagings. In terms of performance validation, we have now a very strong capacity to demonstrate and to measure the morphological changes that we generate, and which are the source of the functional performance improvements. We have already measured a number of performance improvements, but this is an ongoing process. We work through testing cycles, and every time we do a cycle, we see an improvement in the morphological changes and then also in the performance. But we haven't today reached the final limit, the final objective, or we don't know how far we can go into performance improvement. The only thing that we know is that what we have measured so far was deemed by some of our customers as very market relevant. Now, this is where we are. And because, as I said, it's an asset-light company, the main asset of Kerio is the know-how that enables us to define the conditions under which we can trigger the onset of the flow-enhanced nucleation and induced crystallization, and how we have to design the insert that is retrofitted into the machinery. It took us quite a while to build the modeling tool to be able to do that. And there is a lot of know-how there that we keep totally in-house. And the main asset of Kerio is the patents that we have. Today, we have 3 families of patents that are very broad in their geographical scope. We cover Europe, the US, but also another 30 odd countries because we wanted to reflect the footprint of the major FMCGs. And also we are adding patents. We are now at the end of the March. By the end of April, we will have a 4th family of patents that cover an additional application, because one of the fun things when you do development, sometimes you discover new applications that can also be very useful. And so while we were doing the trials at PDG, they said, oh, maybe you can also solve that problem. It turned out to be very successful. And so now we are adding a patent on that item, but I will be able to disclose more information about that in a month or so. And I pushed on the wrong button. Yes. So the fact that we are an IP-driven company that doesn't have assets also influences the commercial model that we envision. And we describe it as a pay-as-you-benefit. Basically, we will give licenses to our technology, to our customers, and the license will be a portion, the price of the license will be a portion of the savings that our technology is generating. So there is no upfront payment to have access to our technology other than the sale of the Kerio products. But as I mentioned, this is these are small amounts, so it's not a CapEx, it's an OpEx. But it will be a licensing model where you pay when the technology generates benefit to your supply chain. Our team is a mix. We are based in Luxembourg, and that was a wish of our shareholders, because being an IP company, the IP policy of Luxembourg is probably one of the most interesting in Europe. We have a mix of full-time employees, the day-to-day management, and some engineers, and then we also work with external consultants that are, I would say, high-level experts in their domain, whether the IP, which is a big investment, or we have a broad support of scientific leads like the Professor Savas Hatzikiriakos, who is one of the most renowned experts in polymer rheology. But we also work with a wide network of knowledge centers like the University of Montreal, who does the characterization of the preforms, the University of Erlangen, but also the EPC in France, that were instrumental in developing several components of our technology. And as we move forward, we will onboard more in-house people, but that was a model that allows us to be on one side very lean, but also to tap into the best minds to develop our science and our technology. We have the chance to be supported by shareholders that have a very strong experience in FMCG, because they were CEOs of large companies, or they are majority shareholders of large FMCG groups. And that's why they really were very supportive of this concept where you improve the sustainability, but you do it in a system that is cost relevant, because from their perspective, they understand that this is paramount if you want to be able to deploy something at a large scale. It's not only about improving the sustainability, it's also about being cost efficient. We're not market ready, but we already have signed various types of collaborations where we enable future customers to have a much more detailed access to what we have achieved so far than the very short presentation I give you here. And this is a very good way for customers to make an evaluation, of all the components, the scientific basis, how we did the industrial de-risking, what are the results that we observed, and that allows, to validate the relevancy of this technology for their packaging mix. And then we move to bespoke trials like we are going to do into the next quarter. And so that's the last slide of my presentation. If you have to remember one item, is we have the pathway that performance follows morphology, and that allows us to have a solution that doesn't require a CapEx expense, that is inherently highly scalable, and that will yield a margin positive sustainability solution. I will add that we focus on PET, but the underlying science and the patent base that we have taken also mean that this technology can be applied and developed for other materials than PET, whether they are fossil-based or bio-based. As a matter of fact, science tells us that bio-based material will be extremely responsive to the concept of flow-enhanced nucleation and induced crystallization. And with that, I've completed my presentation, and I thank you for your attention.
Thanks very much indeed, Tanguy. It's impressive what you showed, and it is impressive the fact that by changing the morphology, then you can change the performance of the final product, and that's something which is in a way unique. And when you say it is the company is IP driven, yes, but I think that it is very soundly, say, driven by scientific findings and scientific, say, research. Thanks very much indeed to all of you. I don't have, actually, I don't have a question and answers on my table, but I have my own questions, a few of them at least, I selected. One is, and again, Nico, nothing personal. I mean, I know I unveiled a part of your presentation unwittingly. And I have one more question, which is a little bit tricky, but I'm just curious, you know, the biopolymer and especially the bio-MEG, years ago, at least to me, but many of the people working in chemicals were aware of the idea that, you know, when it comes to bioglycol or any biochemicals, the cost is basically high compared to the fossil derivatives. Is it still the case, or you know, because of scaling up, because of the new findings that you have, you could say that the situation is not as it was, say, 10 years ago or 15 years ago?
Yes, thanks, Roberto. It's a good question. Certainly, we have improved on that price issue a lot. We estimate that a PET containing both our monomers would roughly cost today about double the price of a virgin PET. So 30% on top of a recycled PET, to just give you some orientation, right? Which is in the bio-based sector probably the most attractive pricing at all at the moment.
Okay. But it's good that indeed the things are in a way improving, because I remember figures which were much higher than what you mentioned. So that's definitely good. Okay, questions are coming. Okay, the first one from Leaf, who left, by the way. It is not a question, but basically just a suggestion that Carbios is indeed very much involved in the enzymatic recycling. It is what we have been discussing in the first part. There is a question from Sylvia, and it is related to the Cairo technology. So which packaging fields can the Cairo technology be applied to potentially? I mean, potentially, which is the field where this technology can be applied? It is only for injection molding, or it can be also applied to other processing techniques?
So it can be applied to other processing techniques, but the focus of our development today is the injection stretch blow molding. But if you look at the underlying science, it is any processing technology that needs a flow and that generates a flow would be subject to the science of flow-enhanced nucleation and induced crystallization. And we have the modeling tool to design the inserts to apply to other processing techniques. It would not be the same insert as for PET ESBM, but it would be the same underlying principle. and I would say the tools to build a processing tool for other processes exists. It is just that when you are a company like ours, you focus your resources on one item. Now, this being said, we've had many questions from other industries to see whether the technology would be applicable. And we're always open to discuss, collaborations and how we could do that and how we could tap into the existing knowledge that we have acquired to start a different development track.
Good, great, thanks. And since we're touching that point, you mentioned that, of course, you are going to expand the cooperation with potential customers, and therefore also your collaboration program is going to, say, expand, increase, being boosted. Can you elaborate a little bit more? Which is the customer portfolio, if I may call it that way, that you are targeting? Because clearly your technology seems to me very versatile. So, if you can elaborate a bit more on that.
I think you use the very right word. It's versatile. It will depend on the dynamics in the supply chain. We have already signed contracts, evaluation contracts with large FMCGs that are interested by the technology for their packaging mix. And by taking a license that allows them to have some freedom of their supply chain and see how they deploy the technology. Now, this is not necessarily a model that will work for everyone. We know that the dynamics of the supply chain will depend on the size of the stakeholders. As mentioned previously, we at Carrier, we all come from AB InBev, which was a company that was very strong into putting pressure on its supply chain and go through systems of see-through margin analysis. And I think you've been on the other side of that.
Indeed.
But depending on the size of the stakeholders, the license might be in the hands of the converter. PDG has a number of very small customers, and there you would have a different model. What matters for us is that our technology creates a margin, and then you have to find the right model to capture the margin and to deploy it. And that's why the licensing model offers a great flexibility to adapt to the various market dynamics.
Thank you very much. And Ben, I think you already answered in your presentation, but just to be sure that I captured rightly what you said, this technology can, of course, apply to different kinds of polymers, and also, of course, the bio-based polymers, because ultimately bio-based is just differentiating the polymer based on a different source, different from say, the fossil. But basically, I think that you can confirm that your technology can indeed apply to our, say, polymers when it comes to produce packages, right? I think the Tanguy was frozen, probably.
Oh, sorry, the question was for me?
Yeah, sorry. No, well, more than a question was just to be reassured that indeed what I captured in your presentation is right. So what I was saying is I understood that your technology can be applied to our polymers, other than PET, can be used in many different fields. Yes. Biopolymers as well, because biopolymers, the difference between biopolymers and standard polymers is only the nature of the feedstock, which comes from either non-fossil or fossil sources.
No, sorry, I thought you were the question was for someone else.
Yeah.
Yes, no, in theory, if you look at the science, it works with biomaterials. We had long conversations with PLA producers because PLA has performance challenges in terms of heat resistance. And so they saw technology as not a way to reduce cost, but as a gateway to applications that are today not possible with the current way of crystallization of these materials. So yes, we also talked, with wheat, algae-based materials that want to venture into new applications, and they also hit performance challenges. And so they're very interested by that. The difficulty is that to do that, you need to have a very good understanding of the rheology of your material. And that is a knowledge that is very often between the material producers and the processors. So no one really controls or has a full understanding of that. And we've seen that some seaweed producers, for instance, don't fully understand their material. If you don't fully understand your material, it's hard to apply the technology.
Yeah.
In principle, yes, it is possible. I would say the main barrier is a barrier of resources to look at that.
Okay, thank you very much indeed. I have from my side one last question to Lisa. You presented your activity and all the very interesting work on NIAS. Now, I'm curious to understand if in your company you have, for instance, a team or a way to monitor the changes which are happening in the market in such a way that those changing, if they are influencing the potential NIAS picture, which means if there are changes in the market that will probably generate a new kind of NIAS. Is there a way that you can monitor that? And by doing that, of course, you then adapt your, say, lab analysis and lab methodology to be able to capture also those potentially new NIAS.
Yes. Thanks for the question. I skipped a lot of our services, but internally we are developing a software like a platform where our technicians register all the findings related to the sample, the specific sample, to the customer, to the kind of material, and to the date, of course, of analysis. So we are able to monitor the changes and which are the particular NIAS for all the different materials. It is really an added value for us because I don't know how much you are confident with chromatograms, so with spectra.
Well, okay, I'm a chemist, but you know,
Okay.
several things. Well, right by now, I forgot several things, so don't trust too much my memory.
No,
Yeah,
no,
I'm
no,
a chemist. I'm a chemist.
It doesn't matter. It doesn't matter. But the important thing is for you to remember how the difficulty is to understand which kind of substance you are you're watching, and with this kind of database, we can be more confident. Much more confident for the findings for the identification of the findings. And the other thing is that we are tailoring our NIAS screening according not only to the standardized test conditions, but also to the analysis in food. It's really complex because, you know, analysis in food are not that easy to be performed, but after an analysis like a standard analysis with the same time temperature condition than the food, we performed an analysis with fries, with French fries and ketchup to verify the possible interactions with food of this biopolymer. It was a biopolymer. So after the analysis with a polar solvent, ethanol, isoctane, and I don't remember which other one, then we verify the peaks found in the fries after the purification, of course, the sample. But we have fun enough here in the laboratory.
Great. Oh, great. That's excellent.
Yeah, my technicians hate me because I'm a sales representative, so I'm the one who invent strange things time after time.
So you are very creative, not only a scientist, but also very creative. Okay.
Just a little bit, yes.
That's good. Well, thanks very much. I don't see any other question coming in. then if that's the case, first of all, I really would like to thank all our speakers. They've been, in my opinion, very good in presenting their companies and their activities, but at the same time, they gave us a lot of food for thought. I also would like to thank very much the attendees, people that decided to join us today in the webinar. And I hope it has been as interesting to them as it has been for me. So thanks very much indeed, and have a nice rest of the day.
Thank you.
Bye-bye.
Thank you very much. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.
Bye-bye.
Bye.